When the perimeter of a rhombus is equal to 40, we can divide that by 4, and we find each side is equal to 10. If a diagonal is equal to 12, we can divide that by 2, and we find each of the two segments, in this case DE and BE, are each equal to 6. Then we can look at a right triangle over on the right hand side of the diagram, use the Pythagorean theorem, and we solve for x, and x is equal to 8, which is the distance from A to E. Also, it's the distance from C to E, which makes the distance from A to C equal to 16. If the angle at the top of this rhombus is equal to 64 and opposite angles are congruent, the angle at the bottom is also 64, and consecutive angles are supplementary, so the angles on the sides are each equal to 116. When you have a rhombus, the diagonals of the rhombus are perpendicular. That makes angles 9 through 12 equal to 90. And if the angle at the top is being bisected, that makes angles 1 and 2 each equal to 32. And if you look at the triangle on the right hand side, those three angles have to add to equal 180. So therefore we can solve for angle 3, which I'll call x, and x is equal to 58. If angle 3 is 58, angle 4 is equal to 58 because the angle is being bisected. And then if you look for alternate interior angles, such as angles 1 and 5, or 2 and 6, or 3 and 7, 4 and 8, they're all going to be congruent to each other.